Welcome to Tech Tuesday number 13. And today we're going to talk about the shape of the solution space. And here's three pictures that I took on recent road trips. And imagine that each tree is a solution to the technical problem that startup. On the upper left, you have the desert. Can you hear me? Okay. You have the desert. You see there's only a very small number of trees and they're far between. Underneath, we have trees, but they're not so dense. They're separated one from another. And in the upper right corner, we have basically a forest. The trees are touching each other. Now, also, when you have technologies and you have a problem to be solved, the solutions can look like that. The solution could be there's only one or two. The solution could be there are quite a few, but there's distance between them. Or it could be it's continuous. You have a solution, you move to the right, you have another solution. You move to the left, you have another solution. In each one of these, you should have different IP strategies. So why is this? Well, if we look at a basic goal of the patent as preventing the competition from providing a solution that can compete with you, then if you're in a field where you have lots of solutions and you covered one of them and the competition can find another one, so the patent is not very useful. At the same time, when you file a patent, it publishes and it exposes your ideas, insights, and technical information. And you have to ask yourself, will your patent prevent the competition from using them simply by moving to a different tree? In fact, one of the insights that you can provide is what the solution space looks like. Could be people don't understand what the solution space looks like. And last but not least, technology evolves. And the way the technology evolves is different in each one of these spaces. And your IP strategy needs to take this evolution into account. So knowing what your solution space looks like, I think is very important. And whoever joined, please mute. Now, there's two types of densities, and I'll give you two different metaphors to look at it. So in one of them, think about an island, a desert island in the middle of the ocean. Well, the more you know, the bigger your beaches and the more you can know. So even if the density is going up and up and up, so is the potential space you can go in. But in a different type of world, it's more like the game Battleships. I don't know if people still play it, but basically when you play Battleships, you choose a coordinate point and you press on it. There's a limited number of coordinates, and as you put down more points, the world becomes denser and denser until there's nothing left. And it means that in the first world, the value of the IP you can get, ignoring all other considerations, keeps on going up. Okay, first I invent a computer. Then I invent the home computer. Then I invent the microchip that goes in the cell phone. Okay, then I invent ChatGPT that runs on the microchip that goes in my cell phone. So the more you invent, the more value you can get. And in the second case, I don't know, let's take the example of a toilet seat, which I'll get to later again. Once you have 5 different designs of toilet seats, it's true that the design space is big, but added value keeps on going down, and the scope of patent you can get also keeps on going down. So a closely related concept is the maximum possible value creation and extraction. We go back to the microchip. If we have super AIs that costs nothing, the value we can get is infinite, because one AI can do the work of 10 million patent attorneys and get paid like some. But if we talk about toilet seats, there's a limit to what value you can get out of a toilet seat. And I admit, some people could discover new ways of doing it. But in general, in the field of toilet seats, people are going to pay $3,000 max for toilet seats, and that's all you can get to. So again, the shape and the density of the solution space really inform both your IP strategy and the potential value of your IP. Now, I mentioned solution space density, but what does density mean? So imagine that the y-axis is value and the x-axis is solutions. And each one of these three dotted lines are what we can call suitability. So if we go back, a few thousand years, having fresh bread every day is suitable solution. And if we go to the 21st century, if you can't have a delivery of 5 different kinds of food within 25 minutes, so it's not a suitable solution for eating. So at the lowest level of what the market considers to be suitable, it looks like the solution space is very, very dense. But if you were able to increase, or perhaps it happens naturally by itself, where people's standard of living goes up, people's expectations go up, you can encourage people to expect more, then the density of the solution space goes down and down as the suitability goes up. So you have to ask yourself, is it possible that by providing the solution, which is incredible, you will change the market's concept of what is suitable? And as a result, the space, instead of being very dense, suddenly becomes very sparse, where we'll talk about the protection, but obviously the protection can be better. You can especially find that in things like medical or safety. Okay, but in medical, if everybody has something that helps cure cancer, that's fine. But if I can give you a pill that makes the cancer go away with no side effects, the solution space suddenly becomes very, very sparse. Because even though there might be a lot of cure for cancer, nobody is willing to use them if they have a solution with no side effects. I talked about the density, and now let's talk about how easy is it to get from one place to another. So you can see here 3 different textures. In the background, you have the black peaks. Obviously, getting from one peak to another peak is a lot of work because they're high and far apart. In the foreground, you have the yellow peaks. It's much easier to get from one peak to another. But on the white gravel, it is really easy. You just walk and you get to another spot. And some technologies are like that too. So what I call travel means how easy is it to search for a new solution. I want to point out this is independent of the question of how many solutions are there. Okay, there could be a lot of solutions, but it's very difficult to move from one to the other. There can be a few solutions, and it's very easy to move from one to another. So the way I see it, when traveling is easy, the exploration rate in the field will go up. And that means that at least your more sophisticated competitors, they'll be very happy not to copy your solution. And somewhat related to this is user habits. If users have a habit of using your solution, it is possible that they will not agree to travel to a different solution. Last but not least, how do you know if you got it? So here we are in the middle of the desert. The road is going in all directions. Are we there? Behind the photographer, maybe there's a beautiful village with an inn and cold water. Why do you have verification costs? Sometimes you have to do an experiment. Experiments can be easy, can be expensive. Sometimes you have to get FDA approval, which of course is usually quite expensive. Sometimes you need client acceptance. Depending on the client, it could be easy or difficult. It could take you a long time to build a prototype. And if you read the paper put out leaked supposedly by Google, they were complaining that open source AI is beating the pants off of them because they're able to do much smaller models and run them much faster and get feedback faster. While in Google, they were stuck for some reason using very large models, which take a long time to build a prototype. Of course, here long is a week versus a day, but sometimes if you're building a fusion reactor, it can be 5 years, 10 years. How long does it take to get feedback? Let's compare a device for treating pain to a device for preventing Alzheimer's disease. The first one, you get feedback in an hour. The second one, you get feedback somewhere between 1 and 5 years. Obviously, it's much easier to verify a solution in 1 hour feedback than in 5 hours. So all of these help define how difficult it will be to the competitor to explore. And I try to arrange it as 2x2s using a 2x2 tool developed by a guy called Na. And first we'll look at the left. How difficult is it? And the question is, how difficult is it to prove and how difficult is it to explore? And perhaps I'll go back to my example of the toilet seat in the bottom left corner. It's very easy to find a new toilet seat design, and it's very easy to prove if it's good or not good. In the opposing corner, we have new drugs. They're very difficult to find new drugs and very difficult to prove that they work. In the kitty corners, we have algorithms and medical device. Algorithms are, and forgive me, software people, generally easy to find, but sometimes difficult to prove that they really are good. And medical devices are relatively easy. I seem to have flipped the switches here. Are easy to design, but relatively difficult to prove. So sorry, software, it might be difficult to find a new algorithm, but once you find it, you can check it very quickly. Medical device can be easy to design a new stent, but showing that it actually works is difficult. So how do I think any of this affects IP? I'm reminding that finding depends both on how many solutions there are and how easy it is to explore. If it's easy to find a solution and easy to prove, your IP in general will be very weak because people can just find a new solution, show that it works, and ignore you. If you have something which is difficult to prove, easy to prove but difficult to find, you live in a world of sudden death. Everything's going fine, you have the best algorithm in the world, and suddenly somebody else discovers a new algorithm which is just as good or better, and that's it, you lose your monopoly and your IP has no value. If you live in a world, perhaps like medical devices, the IP is valuable, because while it might be easy to find solutions, it takes you a while to prove them, and during the proving, the IP is preventing the competition from doing that. And we have, perhaps we should call it stable IP. The value of the IP is relatively stable over time. And last but not least, if it's difficult to find IP, find solutions, and it's difficult to prove they work, you get what you have in the drug companies, what I call communities. You have different drugs. Each drug has its own halo of technologies around it, but often you don't have direct competition. Okay, if you think of Viagra and Cialis, those they are competitors, but it's different technologies and the product is different and each one has its own niche. So, an interim summary. What we want to do is to make it difficult for the competitor to explore and find solutions and verify solutions. And we also want him to not be able to avoid our IP when the competitor does that. I mentioned here an article by Thies, and I'm pointing to a particular section which talks about tight and weak appropriability regimes, which really talk about how easy is it for somebody else to copy what you're doing. And that's why we get to the question, what can we do other than patents? Because making it difficult for competitors to explore could be done using patents, but it's more difficult because exploring is often happens in secret. So, not to forget trade secrets. Okay, if you have a trade secret and people don't have it, it's really difficult for them. Know-how. That is things that people know but is not written down, and complementary assets. I'm not going to talk about other types of IP. Talk for a second about trade secrets. If you keep secrets, maybe you're keeping secrets which make it difficult to do provability, maybe difficult to explore, maybe difficult to know what the solution space looks like. Something as simple of what jig setup should you use for an experiment in order to make it easier to do the experiment. Survey data telling you what people want or don't want. A new way of drug discovery. And I've said before, there's not enough of this, but opportunity for deception. If you can convince people that the solution space looks different than what it actually looks, you can change the way they do R&D. Your publications, especially patent publications, but also others, can do that. Example, it was told to me once, somebody filed a patent on a feature which was not important, but they made it look like it was important. And that somebody spent a whole year delaying his product, trying to design around the patent and failing until they gave up and decided to do without the feature and discovered nobody needed that feature. Okay, wonderful example of deception. I wish I had more. Know-how. So know-how by its nature is not published. It's usually tied to people. You need to maintain it. People leave, people stop working on something. You have to be really worried about people moving to your competitor. Again, that same Google document talks about that problem. So there's a link between know-how, trade secrets, and confidentiality. And here's a classic example. How do we clean the data before we give it as an input to the machine learning? If you do good cleaning, you can get much better learning. If you don't, oh well. Complementary assets. So you're selling a product, but that product is used together with other things. And classic example, 20, 30, 40, 500 different car designs out there, but they all drive on a road. If you somehow get a monopoly on the road, it doesn't matter that your competitor has a different car design. So when we talk about the sparsity and the explorability and flexibility perhaps of the solution space, we should also talk about the same properties of the complementary asset space. And not all complementary assets are protected using IP. For example, distribution channels. If you have a monopoly on distribution or a monopoly on the only manufacturer who knows how to make some sort of raw material, You don't need specific IP. You can just win on that. Okay, I'm going back to these pictures. I want you to notice that the sky is empty. World is three-dimensional, or patterns IP in general might only be two-dimensional. Second point, we talk about the density of solutions. What about the density of IP? Okay, if there's a lot of IP out there, it could be that you can't get broad IP. Think about the game's battleships. You can't get IPs that cover somebody else's colored pins. And last but not least, what about IP owned by other people? Is it a problem? I didn't talk about it, but it doesn't mean you shouldn't be thinking about it. For an example, let's think about 4 different companies. One is developing a new drug. One is developing a new high-yield integrated circuit manufacturing process. One's developed a new toilet seat design. One is developing a new coronary stent. Ask yourself, for each one, how dense is the solution space? The toilets, I can already tell you, very dense. How easy is it to explore? How easy is it to know that you got it? And as a bonus question, what if you're wrong? What are you going to do? I am stopping the recording.